Hello all, I am Dr. Rizvi and this is part 2 of our lecture on bending equation. In this lecture we will solve a numerical on bending equation. So let us start with the numerical. Here you can see that the numerical says that a beam of rectangular cross section having depth of 250 mm and its width is 150 mm. It is subjected to a maximum bending moment of 750 kilonewton meter. We have to determine three things, that is maximum stress in the beam, second is the value of radius of curvature at the portion of the beam where the bending moment is maximum. We have to take the value of E as 200 giganewton per meter square, and the third part is that we have to find the value of longitudinal stress at a distance of 65 meter from the top surface of the beam. So this is the uh, numerical that we have to solve. The depth is given as 250. The cross section of the beam will look like this. Its depth is 250 mm and its width is 150 mm. This is the neutral axis. We have to find the maximum stress. So let us start with the numerical. Before starting the solution, we'll first write all the given things in the numerical. So we are given the width of the beam B equals to 150 mm. Since all the calculation are in meters, so we will convert it into meter and it will be 0.515 meter. The depth of the beam is 250 mm, 0.25 meter. The maximum bending moment for the beam is given as 750 kilonewton meter, and the Young modulus E is 200 giganewton per meter square. These are the given part. Now let us calculate the first part, that is the maximum stress in the beam. Maximum stress in the beam. Before finding out the maximum in stress in the beam, we know that the bending equation is M upon I equals to sigma upon Y equals to E upon R. So if we have to find the maximum bending stress, we must have the other values too. We have the value of M, we have the value of E, and so first we will find out the value of I, that is moment of inertia, and I for the rectangular section is B d cube upon 12. Here B is given as 0.15, D is given as 0.25 to the power 3 whole divided by 12, and this will come out to be 0.001953 meter to the power 4. Now we have to find the value of the distance of neutral axis from the top surface, that is y. Y will be half the distance of the depth, that is 0.25 upon 2, it is 0.125 meter. Now we have the value of y, I, m. We can find the value of sigma. So making sigma as subject, sigma will be equals to m into y upon I. M is given as 750 into 10 to the power 3 because it is given in kilonewton per kilonewton meter into y 0.125 whole divided by 0.000195 So the maximum stress is coming out to be 4.8 into 10 to the power 8 Newton per meter square, or 480 meganewton per meter square. This is first answer of our numerical. Secondly, we have to find the value of radius of curvature. We have to find the value of radius of curvature r. For this, we know that from the relation here, m upon I equals to E upon r. So r will be equals to E into I upon m. And we know the value of E as 200 into 10 to the power 9 into, we know the value of I 0.000195 whole divided by the value of m 750 into 10 to the power 3. From here we will find out the value of radius of curvature, and it is coming 52.08 meter. This is the second answer. Now we'll move on to the third part of our numerical, that is we have to find the longitudinal stress at a distance of 65 meters from the top of the beam. Here you can see that we have to find the longitudinal stress at a distance of 65 mm from top of the beam. Here we have to find the value of sigma at this point. Let this be sigma x or sigma 1, anything you can assume. Since the ratio of sigma and y is constant, that is sigma upon y equals to sigma 1 upon y1, and this is equals to m upon I. So we will use this relation and we will find the value of sigma 1. So sigma 1 will be equals to m into y1 upon I. The distance y1, this is from the neutral axis. So total distance is, the total distance is 125 and this distance is 60. Since this is 65, so y1 will be equals to 60 mm. Now we'll place the value of m, y1 and I. M is 750 into 10 to the power 3 into y1 is 0.06 whole divided by I is 0.000195. From here we can find out the value of longitudinal stress at a point which is at 65 mm from the top surface of the beam, and it is coming to 30.4 mega Newton per meter square. So this is how we solve our numerical related to bending equation. Thank you.